Hello dear students, welcome to Pen and Paper Chemistry on YouTube. I hope you are preparing well for your upcoming examinations. In this video, we are going to do justice to this chart that we had drawn long time back, but I think somewhere we missed out writing the chemical reactions. This is a flow chart indicating the preparation and properties of alcohols, and believe me, this is very, very useful. So please make sure that you have your pen, paper and some colored pencils or sketch pens ready so that you can draw this flow chart in case you have missed it. And also I'm going to post it on the Google site Pen and Paper Chemistry, so you can also download it from there. Based on this flow chart, we've got the preparation of alkenes, and the first preparation we are going to do of alkenes is by hydration. Hydration in the presence of a few drops of concentrated H2so4, or first acidification followed by hydration. Now, if you notice over here, MP, Markovnikov product by Oxymercuration-demercuration as well. So, first three are giving us a Markovnikov product in the case our alkene is unsymmetrical. Whereas hydroboration oxidation gives us an anti-Markovnikov product. Confused about all the terms that I'm using over here? You need to go back to the videos on alkenes in order to clear your concept, because we have a separate detailed video on this. Although in today's video also we'll touch base on a little bit of mechanism here. So in the preparation of alcohols from alkenes, the first method that we've got is hydration with dilute H2so4. So CH3, CH double bond CH2. This is the unsymmetrical alkene that we are taking over here. You see over here CH2 double bond CH2. If I write it in this form, expanded form, CH2 double bond CH2, the two parts are mirror images of each other. This becomes a symmetrical alkene. Whereas if I replace one of the hydrogens by an alkyl group, so as I have done above, CH3, CH double bond CH2. Now if we write this structure in an expanded form, CH3, CH double bond CH2, are the two parts mirror images of each other? No, they are not. So that means it's an unsymmetrical alkene. We have taken more examples, discussed them in greater detail under the heading of alkenes. So in the examples, in the equations that I'm going to write over here, I'm taking an unsymmetrical alkene, and the name of that unsymmetrical alkene is propene. Propene on hydration gives us Markovnikov product. What does Markovnikov rule say? Positive part of the adding reagent goes to the carbon bearing more number of hydrogen atoms in an unsaturated carbon. Right? Again, as I said, this is a topic more related to alkenes. Hydrogen positive, OH negative. I've got the doubly bonded carbon. These are the two unsaturated carbons that we are talking about. Now look at the number of hydrogen each one of them has. This carbon has only one hydrogen directly attached to it, not through the carbon. Or whereas the second carbon has two hydrogen atoms directly attached to it. So the positive part of this reagent will go to the carbon, to the doubly bonded carbon bearing no more number of hydrogen atoms. Question: why doesn't this positive carbon go to this carbon, the positive hydrogen go to the carbon bearing 3 hydrogen atoms over here? Yes, it is fully saturated. You see the CH3, it's actually CH3. It's fully saturated. It's not going to undergo addition reactions. So that is why we are saying to the unsaturated carbon atoms over here. So the positive part goes to the carbon bearing more number of hydrogen atoms. So CH3 remains as such. CH gets an OH and then CH3. To derive maximum benefit from the channel, please make sure that you keep pausing and writing the reactions as I am teaching over here. That is why I rename the channel as Pen and Paper Chemistry. We write and understand and learn chemistry. It is not sufficient to just watch the video. How do we name this compound? So we've got here 1, 2 and 3. So the name of this compound would be propan 2-ol. So what kind of an alcohol is this? Yes, it's a secondary alcohol. Right? Good going so far? So this is Markovnikov addition of water across the double bond. Let's take the second one. Now the second one says that the preparation of alcohol involves the treatment of the alkene with concentrated H2so4, that is 98% concentrated H2so4, which gives us the alkyl hydrogen sulfate. This on hydrolysis gives us again the alcohol based on Markovnikov rule. So let's write the reaction. So we first take again the unsymmetrical alkene CH3, CH double bond, CH2. Treatment with concentrated sulfuric acid, 98% concentrated H2so4. Now look at the way that I have broken it down. Let's make it more specific and we have it written as OSO3H. Again, apply the Markovnikov rule. Positive part goes to the carbon bearing more number of hydrogen atoms. So we have over here CH3, CHOSO3H, single bond. See, there's an addition reaction taking place. So double bond changes into a single bond. Now this followed by hydration, that means treatment with water. What will happen? This will break down and we will have OH and H here, CH3, CHOH, single bond CH3. If you don't want to write the steps like this, you can also write the reaction directly leading to the formation of the products. And if you notice carefully, this reaction is simply involving the Markovnikov addition of H2O across the double bond, just like we had done in the previous mechanism or the previous reaction. So if we are talking only about alcohols, even a direct reaction like this showing the formation of the products would be sufficient. Again, let's name the product. This would be propan 2-ol. Right? And what kind of an alcohol is it? Yes, a secondary alcohol, which is also written as a 2-degree alcohol. What is a 2-degree alcohol or a secondary alcohol? Look at the carbon carrying the OH group. That carbon is bonded to two other carbon atoms. Look at the functional group. It's CHOH. It's a secondary alcohol. Have you written it down? Are you writing it down? Are you writing the reactions with me in order to derive maximum benefit? Be honest. The next method of preparation from alkenes involves a series of two steps. So the first one is oxymercuration followed by demercuration. Now as you can see, mercuration means something mercury is involved over here. So we have a compound of mercury, that is mercuric acetate, which is made to react with the alkene to give us an addition product. What is that product? We're going to write it in a while. Followed by reduction to give us an alcohol. Now this reduction releases the mercury which is added across the alkene. That is why this is also known as demercuration, removing the mercury bit. Now if you are here only looking at the topic of alcohols, we can also simply write the reaction as the alkene. Again, I've taken the example of an unsymmetrical alkene. First step involves oxymercuration. The second step involves demercuration, giving us again a secondary alcohol, and that secondary alcohol in the present example is again propane 2-ol. I am taking the same alcohol in all the examples so that we have clarity regarding the products. Now coming to the steps. First of all, remember CH3CO. In short, you will find it written as AC at a number of places, which is acetyl group. You add one more oxygen, so OAC, and now it becomes acetate group, CH3COO. Why I am telling you this is because the next compound that we are writing over here is mercuric acetate. So at a number of places, this mercuric acetate would also be written as HgOAC. You see over here the acetate bit and whole twice. I'm telling you this so that when you read books from different authors, you should not get confused. So the first step involves the addition of mercuric acetate. Again, a Markovnikov rule, just keep the things simple. So we have the positive part here and the negative part here, right? So positive part and negative part, again positive part goes to the carbon bearing more number of hydrogen atoms. I'm giving you a simplified version of the steps of the reaction. This is not exactly the mechanism. The reaction takes place in tetrahydrofuran is the solvent and water. So we have, if you notice, across the double bond addition of OH and HgOCOCH3. So we are forming an addition product over here. Usually, we do not stop the reaction at this point. We carry out its reduction using sodium borohydride in an alkaline medium, OH negative. So what happens over here is the mercuric acetate bit disappears, replaced by hydrogen, and we'll have of course gotten CH3COOH from here as one of the side products. Again, as I said, you can always write the reaction in one step like this, writing the first step as the reaction with mercuric acetate in tetrahydrofuran and water, followed by reduction. So when I write first and second, that means these are the two steps of the reaction, and after these two steps, we form the product, which is again propane 2-ol. As explained earlier, since we are carrying out mercuration followed by reduction, at number of places you will find this reaction written as oxymercuration reduction. Now the three methods that we've done so far, that means hydration followed by treatment with dilute H2so4, or treatment with acid first followed by hydrolysis, or oxymercuration-demercuration. Each one of these reactions involves the Markovnikov addition of HOH across the double bond, right? So we are getting a Markovnikov product in all the three cases. Let's see the fourth one, that is hydroboration oxidation, where what we do is we treat the alkene with diborane. The product that is formed is oxidized to give us the alcohol. Notice here what we've got. Yes, an anti-Markovnikov product. So let's write down the reactions for this. Hydroboration. Hydroboration, as the name indicates, is done with borane or diborane. So you notice over here I've written BH3, which actually exists as a dimer. So we write it as B2H6. Both are acceptable. So successive alkylation. So basically the hydrogen is replaced by the alkyl group. Now the hydrogen doesn't have any place to go. So what does it do? It goes and adds itself across the double bonded carbon to the carbon bearing lesser number of hydrogen atoms. So what we'll get over here in the products is CH3. See, I'm going to write from here, starting from here, CH3, CH. Now the hydrogen has got added across the double bonded carbon. CH3, CH2, CH2. This is going to take step by step and we will have boron at the end. So this gives us an a substituted product which is called as trialkyl borane. This is not the mechanism, just trying to keep things simple for you. Now the product which is formed is oxidized in the presence of, with hydrogen peroxide in the presence of an alkali. Hence the name of this reaction is hydroboration oxidation. Now oxidation of this gives us CH3, CH2, CH2OH. Remember, these are all what we call as skeletal equations. We don't really balance them. You notice I am not writing any of these side products over here, because in the organic reactions there are quite a few side products and we don't want you to confuse yourself at this point of time. Notice the product which is formed over here. We've got the starting alkene as propene getting converted into, what have we got over here? How are you going to name this compound? Yes, it's propanol, which is a primary alcohol, right? A 1-degree alcohol. That means this product is very much different from what we have formed in the earlier reactions, where everywhere I was getting propan to all. So this is a very good mechanism or method of converting an alkene to an anti-Markovnikov alcohol. That means an alcohol formed by the anti-Markovnikov product. Right? Are we writing this down? This will come in very, very useful when you are doing conversions. Going up the series, down the series, this will be very, very useful. Now please remember that in these reactions that I have written, I have not taken any of the rearrangements into consideration, which are a bit higher level. We have to deal with them separately. This is just to make things easy for a beginner, and I sincerely hope that we've been successful so far. We shall be continuing with further preparations of alcohols by different methods using this chart. So stay connected and be ready for the next video. See you there.